Chapter 7, number 27. A 2,100 kilogram pile driver is used to drive a steel I-beam into the ground. The pile driver falls 5 meters before coming into contact with the top of the beam, and it drives the beam 12 centimeters further into the ground before coming to rest. Using energy considerations, calculate the average force the beam exerts on the pile driver while the pile driver is brought to rest.
In this problem, we're given the mass of the pile driver is 2,100 kilograms. The distance the pile driver falls before it hits the beam is 5 meters, and the height that the beam is pushed down is 0.12 meters. And in this problem, we're asked to find the average force of the beam, and it gives us a hint to use the law of conservation of energy. So as the pile driver hits the beam exerts a force on it as well. So we use the equation, the sum of the work is equal to the change in kinetic energy. So the work of the gravity plus the work of the beam upwards is equal to 1/2 mass times velocity final squared minus 1/2 mass times velocity initial squared. And as we know, work is equal to force times distance times cosine theta. So we use that in our equation. And then the force of gravity, or the work of gravity, is mass times gravity plus d, the distance it falls, plus h, the height that it goes into the ground, times cosine of 0 since it's going down. And for the force that the beam exerts, it's force times distance, how far it goes into the ground, times cosine 180 degrees, since the beam is pushing upwards, which is 180 degrees from what gravity is doing. So, and this is all equal to 1/2 mass. Since the velocity final is 0 and the velocity initial is 0, we get it's just equal to 0. So we come up with the equation, mass times gravity times height plus distance is equal to 1, since cosine of 0 is equal to 1, plus force average times distance times -1, since cosine of 180 degrees is -1, is equal to 0. So then we can simplify this out so that mass times gravity times h plus d minus the force average of the beam times distance is all equal to 0. And we move that over to the other side to get mass times gravity times h plus d is equal to force average times d. So we can simplify this to get force average all alone. So force average is equal to mass times gravity times h plus d all over d. And we have these all from our given, so we can plug in the numbers to get force average is equal to 2,100 kilograms times 9.80 meters per second squared times 5 meters plus 0.12 meters all over 0.12 meters. And when we multiply all this out and divide it, the answer is the force average is 8.78 times 10 to the 5th newtons. And since the beam is doing work upwards, the force on the pile driver is upwards.